Dear students, today we are going to study about SLO number 1.2.2 that is related to the concept of mole and Avogadro's number. So today we will be discussing the mole and Avogadro number in detail. Let us start. To relate the concept of mole and Avogadro number, we have to first understand the unit formation. Like if I write second, so directly it comes in my mind that I'm talking about time. If there is something written in kgs, so we are talking about mass. Similarly, if it is written in liters, so we are talking about the volume. Right? So these are some identification for the writing, like the units are just going to give us the clear idea what we are talking about. Is there any unit for the mass of atom or molecule? You might have noticed that there are some units which are going to use for particular representation. Similarly, for the mass of atom, we are going to use atomic mass unit as a unit. The AMU represents that we are talking about the mass of atom or molecule or compound, right? If I'm going to write just 23 AMU, that means I'm going to talk about the mass of any substance because it is AMU, and 23 AMU is the mass of sodium, right? So if I'm going to write like 32 AMU, that means I'm going to talk about the mass of some atom that is going to give 32, or a molecule that is going to give 32 in average. So what is the difference between atomic and molecular mass? Or we can say formula mass. To understand this thing, we have to go through the basics, like what is atomic mass, what is molecular, and what is formula mass. Let us recall this thing. The AMU can be expressed in three forms if it is for pure element. Whenever we have a pure element, it is made up of same type of atoms, so it would be represented in a form of atomic mass. Like if we have the element copper, so for copper element, if I'm going to write the mass of that copper element, so it would be represented by atomic mass. So whenever there is a pure substance, it would be represented in a form of atomic mass, right? If we have a compound, now compound can be of two types. Either they can be covalent or they can be in a form of ionic. The ionic representation is only when we have metals in it, right? When we have metals attached with non-metal, they are known as ionic. And what are covalent? In covalent, we have mutual sharing of non-metal. So non-metal with non-metal is, non-metals are covalent. Now, if I'm going to write like CH4, you can easily identify there is no metal, carbon is non-metal, hydrogen is non-metal. So we would call it is a molecule. But if I'm going to write NaCl, so in NaCl, you can clearly identify sodium is metal. So it would be ionic compound. So for covalent compound and ionic compound, representation are different. When we talk about covalent compound, the simplest representation is molecule and their masses are going to be calculated in a form of formula mass, right? So if I'm going to tell that CH4 is a covalent compound, तो अगर मुझे CH4 का mass मालूम करना होगा, तो इसका mass very simply we can calculate 12 into 1 plus 1 into 4. ठीक है, कार्बन का मास 12 है, so 12 into 1 plus 1 into 4, it is 16. 12 plus 4, 16 AMU. Now what it should be called, either molecular mass or atomic mass or formula mass. As we can see, there is no metal over here, so it would be molecular mass. It is a simple molecule and its mass is molecular mass. When we talk about ionic compounds, so as I told you, ionic compound are going to be represented by formula unit. So NaCl is a simple formula unit. We can say calcium chloride, CaCl2. it is also a simple formula unit. So whenever we are going to express the mass of any formula unit, it is known as formula mass, right? So now it must be very clear to you, तीन तरह के हमारे पास masses in a form of mu हम generally calculate करते हैं. These three masses are atomic mass if we are going to talk about the pure atoms. If they are the combination, so non-metal combination are going to be expressed in a form of molecular mass, and it would be expressed in mu. And if it is a metal non-metal combination, they would be expressed in a form of formula mass, and it is also expressed in AMU. Now, why to understand all this? Why we are going to understand molecular mass, formula mass, and atomic mass? There is a significant relationship of these masses with mole. As I told you in today's class, we are going to understand the concept of mole. So I'm going to make you clear about the relationship of mole with AMU. Like if I'm going to simply represent the very pure thing which is easily available in market, that is NaCl. Now, if I want to calculate the mass of NaCl, so what should I do? First of all, I would calculate the mass. I will write the mass of sodium from periodic table. I can see it is 23. And how many sodium? One sodium is there, so I would multiply it by 1. Then I would plus, what is the mass of chlorine? We can see 35.5 is the mass, so 35.5 into 1. So in general, it would be, we can say 58.5 AMU, and it is a formula unit. So if in real life, if I want to purchase NaCl, so what should I say to the shopkeeper? क्या मैं वहां जाके ये कह सकती हूँ कि भाई मुझे 58.5 AMU NaCl दे दे? No, we are going to ask it in a form of gram. Why we are going to ask it in a form of gram? Because the AMU calculation is on atomic level. The atomic level, we can say atom is very tiny. To calculate in a form of AMU, we must have electronic microscope and the special type of instrumentation and expertise to calculate all the masses in AMU. So instead of calculating masses in AMU, we are used to calculate masses in gram, and it is very convenient for chemist and non-chemist person to use gram as a unit. So relate this thing and memorize the concept of mole by this thing, that anything, the any either molecular mass, formula mass, or atomic mass, if we express it in gram, it is 1 mole, right? If it is like 58.5 58.5 gram instead of 58.5 AMU, we would call it 1 mole of sodium. It is 1 mole of sodium. How it is 1 mole of sodium? Because it contains the actual gram which is equivalent to AMU of sodium. So if I'm going to express AMU in a form of gram, it would be 1 mole. So the definition of mole, you can say, is the mass of substance expressed in gram. Let us take one example for molar mass. The molar mass of water I'm going to calculate, because water is commonly used and you can easily understand the example of water. So if we have H2O, H2O. In a form of H2O, we have 2 hydrogen and 1 oxygen. So the mass of hydrogen is 1. I'm going to multiply 1 by 2 because 2 atoms are there, plus the mass of oxygen is 16. So 16 into 1. 1 into 2 is 2 plus 16. It is equal to 18 AMU. 18 AMU is the minute calculation, atomic level calculation. If I'm going to express that calculation in a form of gram, like if I take 18 gram water, so what it would be? It would be 1 mole. If I take 18 grams of water, it would be 1 mole of water, because the mass of formula unit which is present over there, the molecular mass, it is going to be expressed in a form of gram. Let us take one more example. Calcium carbonate. In calcium carbonate, the mass of calcium is 40 into 1 plus 12 into 1 plus 16 into 3. In general, if we calculate, summarize it, so it would be 100 AMU. Instead of 100 AMU, if I generally take calcium carbonate is a white powder. So if I take 100 gram of calcium carbonate, so it would be 1 mole of calcium carbonate. So to relate the AMU with normal life, we are going to use the concept of mole, and the mole is simple representation in a form of gram. So if we want to know the definition of mole, what is mole? The relative mass of atom expressed in gram, like 1 gram atomic mass is equals to 1 mole, or the relative mass of molecule, whatever the mass of molecule is in mu, if we express it in gram, it would be 1 mole. Now, why to understand mole? What is the significance of mole? Here I'm going to illustrate the significance of mole with the help of X. Like if we ask the retailers, they are going to give us X in unity like 1, 2, 3, 4. But if we are going to ask the wholesaler, they are going to sell the eggs in a form of dozen. What is dozen? Dozen is actually the collection of 12 units, right? If I'm going to purchase 1 dozen egg, that means how many eggs would be there? The 12 eggs would be there. So why to use dozen instead of unit value? Because it makes very easy for the wholesaler to make units and sell it in a form of single units. Like instead of counting 12 every time, they are used to make a packet of 12 eggs, and they are going to use it in a form of 1 unit, so the sale and purchase is going to be very easy. Similarly, when we talk about atoms, the size of atom is very small, right? So how many atoms are there, how we are going to deal with them, it was very difficult until we got one collection of atom. Like we have 1 dozen is equals to 12 unit. Similarly, in chemistry, we are going to have one calculation unit that is known as Avogadro number. The Avogadro number is going to represent by Na. It is having the collection of 6.02 multiplied by 10 is to power 23 particles. So if it is 1 mole of any substance, if it is 1 mole of any substance, it would always contain how many particles in 6.02 multiplied by 10 is to power 23. So that is the significance of mole. If we know the number of moles, we can simply calculate the number of particles in it. If I make it more clear to you, if I relate it with the example of real life, so I have a ring over here, right? In this ring, how many atoms of copper are present? I don't know. How many atoms of copper are there in this pure ring? So if I want to calculate the number of atom, which could be in the form of millions, billions, I cannot calculate them randomly. In practical life, to calculate, to have an idea about the number of atom, what can I do? First of all, I can weight that copper pure ring, right? I would weight, let us suppose if it is going to be 56 ग्राम, मैंने इसको लिया कॉपर रिंग को और इसको फिजिकल बैलेंस पर वेट किया, तो ये क्या है 56 इसका ग्राम आया. अब मेरे पास एक पाथवे है जिसके जरिए मैं इसके अंदर नंबर ऑफ एटम्स कितने मौजूद हैं वो मालूम कर सकती हूँ. कैसे? वट एवर दी grams we have taken, we will convert it into mole first. How we would convert it into mole? The mole is equals to gram mass divided by formula mass, right? The mole is what? Gram mass divided by formula mass. So the gram mass is 56 over here. I would divide the gram mass of copper with the formula mass of copper, right? So we would have the ratio of gram mass and formula mass. So I'm just going to put the values of gram mass and formula mass. The gram mass I have taken is 56. The formula mass of copper is 63.5. Okay. So when we will take the ratio between them, it would be around 0.8. 0.88 is the answer. These are our moles. अब हमें पता है कि हमारे पास इतने मोल कॉपर के हैं. इंस्टेड ऑफ number of atom, we are going to step by step complete the procedure. From gram that I have calculated by physical balance, I have converted it into mole. Why I have converted it into mole? Because I know there is a proper relationship between number of mole and particle. There are always 1 mole is equal to 6.02 into 10 to power 23 particles. So here we are going to talk about atoms. So it would be 6.02 multiplied by 10 to power 23 atoms. एक मोल के अंदर हमेशा 6.02 मल्टीप्लाई बाय 10 टू पावर 23 एटम होते हैं. सो व्हाट आई हैव कैलकुलेट इज 0.88 मोल. तो अगर एक मोल के अंदर 6.02 एक्सपोनेंट 23 एटम्स हैं, तो 0.88 मोल्स के अंदर कितने होंगे? We are just going to make a cross multiplication. So to have the single line formula, I'm going to have the place over here. 0.88 into 6. 0.88 into 6 is equals to 1 into x. The single cross multiplication is over there. So 1 into x. Now, if I rearrange it, so I would have 0.88 into 6 divided by 1. तो यहाँ पर जो मेरे पास वैल्यू आएगी, it would be the number of atoms. It is 0.88 into 6. So it is 5.291 atoms. So answer is what? The answer is 5.29 5.29 5.291 5.291. Acha. From previous, we are going to miss one thing, that is exponent 23. I just going to add the as it is value over here because it was in numerator. It is not going to be denominator. So if it is going to be denominator, we would add minus value. But as we can see, the 6.02 over here is in numerator. 6.02 was in numerator. So I'm going to add the value, that is 5.291 into 10 to power 23. That is our answer. The answer is 5.291 into 10 to power 23. These are the number of atoms. So every time when you are going to calculate the number of atom, how many atoms are there, so you have to follow few steps. First of all, if it is a pure element, so you are going to weight it. You have to find out the mass. After finding mass, divide it by formula mass to calculate it into mole. If you would have mole, multiply with the mole by Na, that is 6.02 exponent 23, you would calculate the number of atoms present. So that is the significance of mole. It is going to make the calculations very easy, like the number of atoms, which are very tiny, which we cannot calculate easily. We are just going to have a physical method to calculate them with the help of mole. Hope you enjoyed the video. If you have any question, you can ask me in comment box. Thank you. Your next SLO is related to calculation of these particles. So these particles can be number of atom, molecule, formula unit. In next video, I'm going to use a systematic pathway to calculate all these.